All right, everybody, how's it going? Mr. Cornell here, ready to go over some circle vocabulary for all you geometry students. So circles is a big chapter. It's got a lot of definitions and things that you're going to have to memorize. So do the best you can. Try to go back over it a couple times. This way you don't get too lost a little bit later on as we go through these. All right, so let's start over here with the circle. There it is. There's our circle. And it's a set of all points equidistant from a given point, and we're going to call that given point the center. So there's a center, and all of these distances are going to be the same, and that's what creates this circle. Okay, so there's your center there. So now a radius is a segment that joins the center of the circle with any point. All right, so this is all kind of review right now for you guys. So basically from the center to any one of those points, that's a radius there. Diameter is 2 radii, right? And it goes through the center. That's really important, okay? And it connects these two endpoints there. There's your diameter. All right, so that's baby stuff. So let's move into some more difficult things for you, new stuff for you here. So a chord is a segment whose endpoints are on the circle. So if I drew a chord, let's say this one right here, you're going to say, well, that's a diameter, right? It looks exactly the same. Well, no, because the diameter, well, look at this. It's like a guy wearing a sweatband. No good. I teach math. All right, so the diameter goes through the center, but the chord doesn't. There's your important part. Okay, so yeah, I could draw it there. I could draw another one over here. Okay, it's connecting the two spots there, but they're not going through the center. Okay, that's a chord. All right, now a central angle, an angle whose vertex is on the center of the circle. Well, here's the center. Now, if I'm going to make an angle, okay, the vertex has to be in the middle. So there it is. There is a central angle. I'm trying to remember that because it's in the center, right? That symbol that I drew right there, it looks like this. It's called theta, if you're not sure. And that's what they use to mark an angle. Okay, a semicircle is a half of a circle formed by a diameter. So here's my center. Okay, it can go in any direction. So let's go a little bit off the beaten path here. If I drew a diameter here, this right there, that's the semicircle. And if a semicircle, C-I-R-C-L-E, I got this. Okay, if we know a circle has 360 degrees, a semicircle is going to be 180 degrees. All right. So now, with those two last examples, we're creating what they like to call in geometry an arc, which is a portion of the circumference of a circle. So if you remember, the circumference is measuring that outside distance, right? So if I'm looking at an arc, right, that is an arc, right? So it's kind of moving at some portion along the circumference, okay? So, all right, we're rocking and rolling here. So we just looked at those guys here, but now let's look at what's called an inscribed angle. Okay, so we had a central angle before, and now we're going to look at an inscribed angle. So it's an angle whose vertex is on the circle. So in the central angle, the vertex is the center. Inscribed, it's going to be somewhere on the circle. It can be anywhere. And each side of an angle intersects the circle in another point. So let's say I drew a chord there and a chord over here because it didn't go through the center. That's the inscribed angle right there. Okay, and then here, angle theta. All right, so there's your first page. If you feel like it was going too quick for you, hit pause, go back, rewind. All right, but I'm going to turn the page and keep going. Okay, so now we have, well, we did that one already, a central angle. Okay, so don't worry too much there. All right, so now we have a minor arc, right? So an arc having a measure less than 180 degrees. So if I want to draw that for you, I'm just going to put this here so you can see. That right there is 180 degrees. So if I'm going to describe an arc to you that is minor, okay, let's say I had a point here and I called him A, and I have a point B, it's right there. So here, that's going to be called arc AB. And now I know that this is called a minor arc because it is less than 180 degrees. Well, what happens when you go past 180 degrees? Well, we're going to call that a major arc. And many, many times, not always, many, many times when we're describing, naming, or using major arcs, they like to use 3 letters, right? So say I did, again, AB, but now let's throw C into there, right? And we would call it arc ABC. And it looks like that. So that would go from A, and you got to kind of move in that direction, like you can't go A, C, B. You go from A to B to C. And you see how I went past 180 degrees? Okay, because it would be kind of like right there, that's 180. And you went past it. So that's arc ABC. All right, now you have an intercepted arc, an arc cut in the circle by an inscribed or central angle. So if I drew a central angle here, I can call it center C, angle ACB. Now, the intercepted arc, or the arc that was created, would be arc AB. Now, it could either be from that central angle, which I just drew, but let's use arc AB with an intercepted angle. So, or an inscribed angle. Inscribed means that the vertex isn't going to be in the center, but it would be on the circle. So let's say I drew this. That's an inscribed angle because the vertex is on the circle, not in the center. But it's still sharing points AB, so it's still intercepting at arc AB. All right. Then we have a secant, is a line that intersects a circle in exactly 2 places. So now it's not drawing inside, okay? It's just a straight up line like this. Now it doesn't have to go through the center, it can go anywhere it wants, but it's going to intercept in 2 spots. Okay, then you have a tangent, is a line that intersects in 1 spot, right? So a tangent, it's going to draw a line and it's going to hit in 1 spot. And that 1 spot that it's hitting is called the point of tangency. So this is the tangent line. This is the secant line. And then this, that point where a tangent line hits, well, that's not a good tangent line. That point where the tangent line hits is called the point of tangency. Okay, and that's 1 point. So there's all of our definitions that we're going to look at today. And what I want to do here is we're going to practice those. And I'm going to give you these arcs, I'm going to give you these angles, and you're going to tell me their names based on the vocabulary we just did. All right? So the highlighter works really nice for something like this. So arc BE. Okay, so here's B, and now I have to trace to get to E. There it is. Okay, now this is an arc, right? Now is that a major arc and a minor arc, and why? Okay, well, I'm going to call this one a minor arc because it is less than 180 degrees. All right. All right, now let's go to arc CDE. So I got to trace in that direction. First hit C, then hit D, then hit E. So hit C, then I hit D, then I hit E, right? So arc CDE was half the circle, right? And how do I know that it was half the circle? Well, because this right here is the diameter, and this is half, okay? And what did we call that? We call that a semicircle. Okay. All right, if you want to give a pause and try the other 2 arcs on your own, that would be cool. I'll get set up for this one here. Arc EDF. So trace, first hit E, then hit D, then hit F. Okay, so EDF. There's EDF right there. Okay, so did that go in the major direction, the minor direction? Okay, it had 3 letters. It does not always mean it's a major because it's less than 180, so we have a minor arc there. And then finally FED. Okay, so we'll trace F to E to F to E to D. So here's F. I got to go this way because I can't hit D, right? And I hit E, and then I go to D. Okay, so that went a really far distance. It went past 180 degrees, and remember, past 180 degrees, we're going to call that a major arc, right? So there's some practice with arcs. Okay, now we're going to go ahead and use some practice with some angles. We're going to start tracing the angles. And again, just like the arcs with 3 letters, when you're doing that with the angles, okay, trace it, okay, and take your time with it. So arc B-A-E, trace B, then trace A, then trace E. Now if you notice, where is A? A is in the center. Center is called central angle. Okay. All right, arc BDC. So here's B. Now angle BDC. Then I have to go here to D. Then I go here to C. Look at where D hit. It hit on the circle, so we call that inscribed angle. And finally, angle ECF. So here's E, here's C, and here's F. Again, hit right there. So that is also an inscribed angle because the vertex is on. And remember, when you're in the center, it's called central. So there's some practice with some of those. Here has some answers on there. Pretend like you don't see them until I erase them. There, never existed. All right, let's do it now together. So draw a point on the circle and label it D. That point can really be anywhere it wants. Okay, so try it on your own. Put D somewhere other than the spot that I'm going to put it. It's going to give you the same answer in the end. All right, I'm going to put it right there. Now create angle BDC. So put your pen on B, then wherever you put a point D, trace it and hit D, and then trace it and hit C. Okay, and whether you put it there, maybe you put it over here, and then it's over there. Maybe you put it right over here, and then it's like that. No matter what, we're all going to have the same answer. Angle BDC is called an inscribed angle. Well, why is it an inscribed angle? Because where is the vertex? The vertex is on the circle. Okay, or point D in this case is on the circle. All right, there we go. Let's try the next one. Draw the angle formed by connecting B and C to the center of the circle. So draw the angle formed by connecting B to the center and C to the center like that. Okay, is BAC an inscribed angle? No, because A, which is the vertex, is the center. Okay, point A is the center of the circle. And is angle BAC a central angle? Yes, because the vertex A is the center. Okay, now we now have 2 different angles drawn on this circle. Both of them connect BC, right? So if I connected arc BC, okay, that is the intercepted arc, okay? So think of intercepted like intersection, right? So they intersected at BC. That's the arc. This is the part where it gets a little tricky. You guys don't have protractors to really kind of look at this one, but you know, I'll be the cheater here, and I want you to measure BAC. Okay, they wanted you to measure angle BAC right there with a protractor, and then they wanted you to measure angle BDC, and then it says make a prediction about the relationship between the inscribed and the central. All right, so I don't know, let's make up numbers here, and then you can form your relationship. Let's pretend I looked at this and he was 60. I measured it with a protractor. Then I'm going to measure BDC, and it's going to be 30. Okay? I just know these things. What's the relationship between the inscribed angle and the central angle? That's ugly. Fix that pen. Get lazy. The inscribed angle is half the central angle. There you go. So there's practice for you on some really key and important geometry terms. Stick with me, subscribe, hit post notification, turn them on so that as I continue to go through this lesson, you'll be able to kind of keep up with me to keep up with all of this crazy circle stuff that we're going to be going through with geometry.